Alright, calculus, we're going to try and wrap this up with the final video here. We're still doing more of these calculations of areas and rates and all that kind of stuff. When a plane lands on an aircraft carrier, it must stop very quickly. So a pilot lands on the carrier with the following speed s in feet per second. So this is feet per second, this is t seconds. So it's starting out at 420, goes down to 0 in less than 3 seconds. That is crazy. Estimate the instantaneous change of velocity, the derivative of the plane speed at time equals 1 second. So we could do this a number of ways, but we basically need to find the slope near 1. Well, I know that it's going to be more than, or it's going to be kind of, it's constantly changing because you got this curve that's kind of going like this, and it gets down really fast, and then it slows down to 0. But it's slowing down much faster earlier than it is later, I think. Well, actually, I don't even know. I don't know the numbers, but let's calculate these slopes. So I want to see these slopes here between 0.5 and 1 and these slopes between 1 and 1.5. So let's start with the 0.5 and 1. Our difference in the inputs is going to be 1 minus 0.5. Your difference in the outputs is going to be 230 minus 330. So that equals 100 divided by 0.5. Negative 100 divided by 0.5. Or another way of thinking that is negative 200 feet per second squared. So that's what we're looking at there, because this is feet per second divided by seconds. Now if we were to go on the other side, we're looking at 1.5 minus 1 for the denominator, and for the numerator it's 175 minus 230. So that top piece is going to be 25 plus 30, that's 55, negative, over negative 0.5, which is not quite as big. So we're going to double that. That's actually going to be negative, or positive 0.5, pardon me, negative 110 feet per second squared. So it's probably somewhere in between these. Because if this is the slope before, and this is the slope after. If I can spell after, the slope after. It's been a long day, guys. I'm sure long for you as well. Estimate how far the plane travels as it comes to a stop. Is there any danger in running off the end of a 600-foot carrier flight deck? Okay, so we got to estimate distance. And remember that the area of a rate times time it's going to be our distance. So we got to find the area. Now we can do that trapezoidal rule thing again. So we're going to set this up. Remember, we got 1/2 times the total base, which in this case is from 0 to 3. So that's going to be 3 times, now these numbers in here. So we got 420 plus 2 times the next number, which is 330, plus 2 times the next number, which is 230, plus 2 times the next number, which is 175, plus 2 times 110, plus 2 times 55, plus 0. Right, so let's calculate that. We got 1 divided by 2 times 3 plus, now we got these numbers, let's see what we got. 420 plus 2 times 330 plus 2 times, whoops, that's not 2,330. It's 2 times 330. So I got to insert a multiplication symbol here. Insert, well, not divide twice either. So I'm going to delete one of those, and we'll put times for the other one. Plus 2 times, what's the next one? 230. 230 plus 2 times, after 230 is 175, plus 2 times 110, plus 2 times, I think it's 55 after that, let's double check, 55, plus 0. Now let's put, it doesn't really matter if you have that or not there, but I'll add it just in case. Now something that I'm noticing that I missed right away, this shouldn't be a plus, this should be an open parentheses right here. So now let's calculate this. 3,330. Again, we're missing something. Okay, so we got, let's check something in the formula. So we got half, and then the base. N is the number of rectangles, and B is the base. Oh, you know what? I think we are missing something here. There should be an N right there. That's why that last one was not accurate. Okay, so when we're looking at this, so we B over 2N, or that distance over 2 times N. In this case, the number of trapezoids we have is 1, 2, 3, 4, 5, 6. So we got to do 1/2 right here. We got to multiply this by 6 in the denominator. So let's divide that by 6. Divided by 6. 555. So it only needs approximately 555 feet. 600 feet, close enough? I think so. I think that's why, but I'm not sure. I mean, this could be an estimate, but 600 feet should be enough for this. Let's do the last one. All right, the amount of water that flows over a spillway of a dam is difficult to measure. However, if we know the flow rate, the length of time water has been flowing, we can determine this amount. Suppose the flow rate is measured in thousands of cubic feet per hour. Wow. Is recorded every 2 hours for a 24-hour period. Use the trapezoidal rule to estimate the definite integral of the flow rate. Be sure to specify proper units. So we got that distance. We're going from 12 to 12. That's 24 hours. So we're going to have 24 hours divided by 2 times the number of rectangles. What we got? Let's see. We got 1, 2, 3, 4, 5, 6. It looks like there's 12. Oh, that makes sense because it's split in 2-hour intervals. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, there's 13. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So that's actually 13 rectangles. We've got to be careful with that. All right, so we got 13 rectangles here. Now we got to add up these numbers. So we got 6 plus, now remember the middle ones get doubled. So 2 times 8 plus 2 times 13 plus 2 times 16 plus 2 times 14 plus 2 times 12 plus 2 times 9 plus 2 times 5 plus 2 times 11 plus 2 times 13 plus 2 times 14 plus 2 times 9, and then the last part is just plus 6. Why? Because the first and the last one do not get doubled. In this case, they're actually the same, so that's kind of weird. It's like it doubled by luck. All right, so let's calculate this, and we'll be done for the day, for the week. So that means we got 24 divided by, and now this is 2 times 13 in that denominator. It's going to be 24 over 26 times. So we got 6 plus 2 times 8, which is 16. 2 times 13 is 26. 2 times 16 is 32. 2 times 14 is 28. 2 times 12 is 24. 2 times 9 is 18. 2 times 5 is 10. 2 times 11 is 12. Or not 12, 22. 2 times 13 is 26. 2 times 14 is 28. Let's just add 2 14s in there. Plus 2 times 9 is 18. And then we have the 6 at the end, plus 6. Now something again I'm noticing, I forgot to open and close these in parentheses. So we have this. I got to insert a parentheses in the right place. Right in front of the 6, and then after the last 6. So I'm going to do second, then insert, and then open the parentheses. And down here, we're going to close the parentheses. Let's see what we come up with. So 240. So it's 240 thousands, thousand cubic feet. That is a lot of water. Done. Dun, dun, dun. Oh, wait. Whoops. Number 16. I totally forgot we had number 16. All right, let's see if we can figure out what this is. A new card called the Sexus. Ooh, that's kind of weird. Has its plant next to its only dealership completed. Cards are moved immediately to the lot sold. Suppose the start of the month of May. You know what? I'm going to skip this and we will do this one in class. In class. Why? Because we have time and you should go to sleep. This is you going to sleep, thinking about calculus. You're like, good stuff. Good night.